So I'm going to be talking about significant figures. So what are sig figs? Well, significant figures actually they just help show accuracy in measurements. They do this because anything after a certain point in a measurement, it's guessing. So you always want to be as accurate as possible, which that's when sig figs come in play. All zeros between non-zero numbers are always significant. So any number, any zero that is between numbers that are significant are always going to be significant. So in this example, example A, we have 6.003. All four of these are going to be significant just because the rule above says all zeros between non-zero numbers are always significant. So since the 6 and 3 are both non-zeros, and the zeros are between the non-zeros, it makes the whole equation, the whole number significant. So we have 1, 2, 3, 4 significant figures. Leading numbers are never significant. These three zeros would not be significant because they are leading. So the real significant number starts when a non-zero number comes. So in this problem, you would cancel out the zeros or ignore the zeros, and you would just have two significant figures. Rule number 4 states, not all trailing zeros are significant. Now down here, since we do have a decimal, everything inside here is going to be significant. So we have the 6 and the zeros. So 6,000 is going to be significant because there's a decimal saying it's precisely 6,000. So we have 4 sig figs in this one. When you are adding and subtracting significant figures, you always want to round your answer to the least number decimal places in the question. So what I like to do is I like to put a line down between the last decimal place. I like to draw a line on the last place value, and so that's going to determine how many sig figs are there. So anything before this green line is going to determine how many sig figs you have. The number after the green line is just going to tell you whether to round the 8 up or down. So in this problem we have 26.6. We look at the number after the green line and it's 6, so we want to round the 8 up. So it'd be 6.9, which is 4 significant figures. So when you are multiplying and dividing, the answer must contain the same number of significant figures as the least of all those used in your calculation. So you're going to look for the smallest significant figure in the calculation, and that's how many sig figs your answer should have at the end. So let's look at the first one. So part A, we have 0.71 grams divided by 86.3702 milliliters. So we have a non-zero, and another non-zero, which means we have 3 sig figs. 6 significant figures. And we want to use the least amount of sig figs used in the calculation. So in this case it would be 3. So we want to round off our answer to 3 significant figures. It'll be 0.0, which is not significant, so we move on to 5, 4, 5. So there is our 3 significant figures, and we just want to look to the right of the 5 and see whether we round up or down. This would be grams per milliliter, and that'll be 3 significant figures.